So again, we'll start. So for x, a, we have 2 to the power 2x plus 4x. Like let's say 2 to the power 2x minus 4x plus 5 is equal to 0. So that this x becomes 2 to the power x plus 2. This is A. B, or first we do A. So we're solving for x. And all the x we have is in the power. But in those laws, we had a to the power mn is the same as am n, which was the same as an m. That means that we can write a as 2x to the power 2. And then we also had that if you have a, m plus n is the same as am multiplied by an. So we have negative 2x multiplied by 2 to the power 2, and then plus 5 is equal to 0. This means we still have 2x to the power 2 minus 2 power 2 is 4. Hello?
At first, you wrote 2 to the power 2x minus 4x. Then it's changed to 2 to the power x plus 2. Or that was a different.
So there I was still thinking of a good example. It has come out to be good in this one.
All right.
Because questions may not come directly. That's why we have to have also examples that are not direct, so that we are able to relate. So we have used all the properties of indices to help us reach this far.
Can you start from the first explaining?
From the first line, you have this property here, a to the power mn is the same as a to the power m to the power n, which is the same as a to the power n in brackets to the power n. So that when we have 2x, mean 2 to the power 2x, we can write it as 2 to the power x, everything to the power 2. We also have that if I have a to the power m plus n, the same as having a to the power m multiplied by a to the power n. So we separate the two using these two properties here. So that we have 2x to the power 2 minus 2x multiplied by 2 to the power 2 plus 5 is equal to 0. But 2 to the power 2 is 4. So we write it as 4, and then 2 to the power x remains there plus 5. At this point, we let any variable p to be 2 to the power x, so that where there is 2 to the power x, we put p. Now you notice that it will be squared here. It won't be squared here. Is equal to 0, which is a quadratic, which we are able to solve. The product is 5 and the sum is -4. So we can use +1 and -5. No factors here. So I was thinking there could be factors, no factors. Because the 5 is positive. So what we'll do is we'll use the formula. So P is equal to negative B plus or minus root of B squared minus 4AC over 2A, which is 4 plus or minus 16 minus 20 over 2. So we get 4 plus or minus root negative 4 over 2. So because of the complex inside, we are unable to extract this. We just have 2 to the power x is the same as 4 plus or minus the root of negative 4 over 2. The idea is when you get here, you need to drop the 2 from the power, you know?
Is it okay as in leaving the negative in the root?
Yeah, it's okay.
But don't they say that mathematically?
There's no mathematical wrong with it. It can be anywhere.
So
Yeah.
now what if you say root of negative 1, then again you say root of 4, then you find the root of 4, which is 2, then the root of negative 1, the I, you replace it in that manner. Is it okay?
For now, we're just interested in the value of x, not necessarily to have the simplified right-hand side. So whenever we have a negative inside the root, that is a complex number. But we won't go much into the complexity of it. Ours is how can we extract x so that x can remain alone and n number should be the other side. So in this case, when you get to 2 to the power x, x is still the power, and the other side we have a constant. So what we do here is,
down. What's that coming thing you've written down on 4 plus square root of negative 4? Down. Is it an E or?
You mean this
4
kind of
plus
thing?
square root of negative. Yes.
It's not, it's an arrow. I'll explain. It's not here. So now we want to drop x from the power. So you bring in this number, which is here, is the number you use in log as a base. You do the same on the right. And then since log allows us to drop the power, this power will be dropped and will remain with log 2 is equal to log 2, 4 plus or minus root of negative 4 over 2. But log 2 is 1, so it remains with x is log 2, 4 plus or minus over 2. That's how you extract x from being the power.
So
Hello.
why is the base 2 there?
Because we want to take away the 2 from the left so that x can remain alone.
Since we're replacing this, Nanga, where is the other log 2 coming from?
When you apply log on the left, you do the same on the right so that nothing changes. So this
Okay.
log 2 that has come, you have applied it so that you can get rid of the 2 on the left, but you can't just change the left-hand side. You also change the right-hand side so that nothing changes.
Sir,
Hello.
can you please kindly repeat here when you introduce the aspect of logs here?
So to introduce the aspect of logs, you look at this base here. 2 is raised to the power x, and yet you want to find the x. So you go and bring the log to the base 2. Because you know that log has the property of dropping the power. So x will be dropped from the power to something standing on its own, but being multiplied by the log. The reason why you want 2 is so that you remain with log 2, 2, which you know it's 1. Which you know it's 1. So that x will remain alone. To avoid changing anything, whatever I do on my left, I do on the right.
Sir, what if you don't want to use this formula, but you want to introduce log in the main equation? How do you do it?